So yes, my name is Justin Collins, on Twitter and the internet at large as President Beef. I'll be talking about static analysis today. Right. So I wanted to start off with some definitions in case you need them for the title of the talk. So I think, judging by the talks that have already occurred and the talks on the schedule, you will probably be hearing a lot about continuous security. And in my opinion, continuous security is some kind of automated, always-on processes that are looking for potential security vulnerabilities. And I think this is the way we all want to move towards. This is what you'll be hearing a lot about these next couple days. When I'm talking about static analysis, again, something you're hearing a lot about, this is any information about a program that can be determined without actually running the code. So I have a very liberal definition of static analysis. Some people disagree, but to me, anything you determine about a program without running it, you're doing static analysis. What do I mean by practical static analysis? I mean, I hope that after this talk, you walk out the door thinking, hey, I learned something that I can go and apply, maybe not today, but on Monday when I go back to work. Why static analysis? I'm pretty biased towards static analysis, but that doesn't mean that it is like the best thing, but it does have certain advantages. In particular, it can be fast. And if your static analysis tool is not fast, then you should talk to the vendor of that static analysis tool and tell them you want it to be fast. You can run static analysis essentially anytime, especially when we're talking about source code analysis. Running it anytime is very key to having continuous security. And because of those two things, fast, run at any time, static analysis tends to be easy to automate. And we want to automate it for continuous security. And another nice thing about static analysis is that it tends to point you right at the code that is the problem. And that's just a very convenient thing to have in a security tool. There are downsides, but I'm not talking about them today. So some background, kind of where I'm coming from on this. Last 6 years, I've been working on a tool called Brakeman, which is a static analysis security tool for Ruby on Rails. So my experience is very colored by working with dynamic languages, source code analysis, as opposed to binary analysis or bytecode analysis. I'm not talking about either of those because honestly, I don't know anything about them. In the last couple of years, I've been working on Brakeman Pro, which is like Brakeman, but more pro. So this is kind of the tool cycle. If this is probably familiar to a lot of you. You get a tool, you run the tool, you wait for the tool to run, maybe look at pictures of cats on the internet, and then you get back some results. You or somebody has to interpret the results that come out of that tool. Then somebody, you or somebody else, has to go and fix the issues. And once you've done that, I'm guessing most of you are not working on code that never changes. The code changes all the time, and so you have to run the tool again. And I don't know about you, but the second or third time I've done this, I already don't want to do this again, right? Because as humans, sitting there and running a tool over and over again, it gets old very fast. However, computers don't mind at all. In fact, they're very good at doing things over and over again. So a few years ago, we talked about SADB at an AppSecUSA conference. Does anyone know SADB? Raise your hand if you know SADB. All right. So myself and some colleagues from Twitter, we presented on this tool that we had written, the security automation dashboard. And because of Alex Smolin's logo, I think everyone remembers the crying bee from that talk. It was something like this that we presented, where developer pushes up code, there's a process that's pulling in that code and running Brakeman or other tools, and then pushing it to SADB that would, collect the results and then take some action, email a developer if there's a new issue, or email the security team. And after that talk, and in the years since, there's been a lot of interest in I want SADB, open source SADB, give me SADB. And I'm here today to tell you that no, you're not getting SADB. However, I'm going to give you the tools you need to make something like SADB for your organization. All right, so getting started. Something I've noticed myself is you go to a talk at something like this conference, and someone gets up and they present this beautiful system they've built. They've got the DevOps stuff working, they've got their tooling working, they've got their reporting working, and it looks so beautiful. And you think, I want that. And then you go home and you realize that's a ton of work, right? And you want to go directly from zero to that beautiful picture of everything being integrated. And in reality, people spend a year or two building these systems, so you're not going to get there instantly. So these are sort of my tips for getting started. The first thing you want to do is actually identify a problem. And if your problem is all the vulnerabilities in my web application, that's not specific enough. You should pick one problem. One thing that's really good to go with is if you have repeated security incidents that can all be traced back to the same root cause, you should be thinking about how can I automate detection of that root cause. Another thing to look for is if you have opt-in security. So if you have an API where developers have to do something extra to get the secure version, that's a good problem to look for. And the easiest thing probably is any unsafe method calls or settings that no one should ever use ever. Those are really good things to automate detection of. Once you've identified a problem, then you want to look at identifying a solution. And maybe the solution is, well, I have an unsafe library, now I'm going to write a safer version of that library and hand that to the developers or work with them to develop it. That's a good idea. Moving security from opt-in to opt-out, that's always a good idea. However, you still have that problem of well, people have to switch which API they're using. If you have unsafe calls or settings, you want to be able to detect that. Once we have a solution, we want to enforce that solution somehow. So maybe in your tests, you write some tests that, as part of the test suite of the application that are going to enforce your solution. Perhaps you use static analysis to enforce it, or perhaps you have dynamic analysis on the outside. If you can detect, I always expect the application to behave this way or not behave that way, you can have something from the outside. However, you may have guessed we are going to be talking about this solution. And once you have a way of sort of enforcing the solution, which in this case is kind of detecting the problem, that's kind of the enforcement. Now you want to automate the enforcement. So I'm going to go through sort of these options in detail in a moment. And by in a moment, I mean right now. So these are strategies, and there's no correct strategy here. I'm not advocating any particular strategy. You have to look at the possible strategies and think about how they fit into your organization, your development workflow, and what's going to work for you. All right, first up would be continuous integration. So in this strategy, we have the developer, they're pushing up a branch in Git. And then we have some process, maybe in Jenkins or some other tool, that's going to run our tests or our checks. And if they pass, maybe it merges that branch into development branch or master or something. But if it doesn't pass, it rejects it and pushes it back to the developer. So this is one approach that you can use. Another is maybe you have GitHub and you have a pull request based system. So when you open up a pull request in GitHub, it triggers some jobs, Code Climate, Travis, whatever tool that you want to use. The tools are not really important, they're just examples. It triggers that job, it runs, and again, you kind of get like a yes-no answer out of it, and that actually goes back to your pull request. So it's visible in the pull request, this passed or failed. Another option is to have a deployment gate. So after everything has happened and someone's ready to push the red button and deploy the code, we run one final check, and if that passes, it goes out to the world. If it doesn't pass, it gets kicked back to the developer. I know I wasn't going to say that any of these are right or wrong, but this is probably not the best approach because it's way too late. If you're like blocking deployments, then people are going to be mad at you. But if it works for your organization, awesome. Another thing you could do is sort of the SADB approach, where you have this separate process, it's outside of the workflow, it's asynchronous, and it's pulling in changes, running some tests against them, and then reporting back to the developer or the security team. The advantage here is that you're not, if it breaks, you haven't broken the deployment and development workflow. That part's nice. The bad part is you're not stopping anything, right? You got to make sure it runs before the code actually gets out. Another option, you could just have the tests run locally on the development machine, either as part of your test suite or a commit hook, as part of like, if you're using Guard or some other file system monitoring tool to look for changes and then run tools, that's another approach. And this is like the other end. We got the development gate at the end, like right before deployment, and then we have running tests as the code is being developed on the developer's machine, all the way at the beginning. By the way, your tool has to be fast to be able to do this. All right, so my boss is sitting right in the front row, so I want to be very clear. I work at SurveyMonkey, and this scenario is made up. This is not a real thing, just a motivating example. So at SurveyMonkey, you may imagine we have to deal with a lot of surveys. And we may imagine we have an API, get survey, and you pass in a survey ID. And you get back a survey. Now, in a lot of cases, that's perfectly fine, right? Because maybe we're displaying a survey to someone who's going to take a survey. But any guesses on like a problem that might come up here?
Bots or automated systems?
No, not quite what I'm looking for. All right, so sorry, I didn't warn you about questions at the beginning, so it's okay. So the problem is that we're not checking the user ID here. So this is fine if we're showing a survey, but what if we're editing a survey? Then we need to be able to check the user. So here's our problem. We're not checking the user who's trying to access this, so we have an authorization issue. So the solution is, hey, we'll have a new API, and you pass in the user ID. And of course, the problem is we still have the old API. So what we want to do is enforce our solution by detecting uses of the old API. And we'll use static analysis because that's in the title of the talk. All right, so how do we do the static analysis? Well, you're in luck because the rest of this talk is about how we can do the static analysis. We can start off with regular expressions. Again, I believe this is perfectly fine form of static analysis. Use grep or ACK or silver, whatever it's called, or however you want to do it, use some regular expressions. Here's an example. So we're going to use grep, and our strategy is we're going to match get survey, and then if there are no commas in the arguments, we're going to assume that that means there's only one argument. If there's only one argument, then that's the old API that we're trying to get rid of. You could do something similar with ACK, except here we can say like, okay, only Python files, for example. So once we start doing this, if you start thinking about how would I actually kind of want these tools to work? Well, when I think about it, I think, well, I'd kind of like to just look at the files that have changed and run my rules against that. If nothing matches, we're good to go. If something matches, then print out the files where I found this problem. Does that make sense? Okay. So maybe I write a bash script to do this for me. So I'm just going to pass in a SHA for a commit as an argument. So bash script will check that out. Check that out. And then we need to grab the files that have changed somehow. So we'll run get diff, and I'll show you in a second what comes out of this. We're just going to grab the file names, and then we'll pass those file names to grep. And then grep will print out where it matches. So when we run get diff name status, on the left we get what happened to the file, so added, modified, deleted, and then the file names. We only care about the ones that have been added or modified. If a file's been deleted, it's going to be really hard to do static analysis on it. Just a tip. Okay, so we get the two columns. So you see we're going to grep for things that either start with A or M, and then we're going to grab the second column. So I just want to be like really transparent with you that I am showing you like all the code that you would need to do this. And then we run grep on it. That's cool, I think. That works. You could run it like this, check stuff. That's what I tend to call my files. And then pass in a SHA, and then you'll get out the matches. However, what if we wanted multiple rules? So now we want to take in the files that have changed, run multiple rules against it. If none of them match, we're good to go. If any of them match, we want to print out some kind of warnings for each one. So what we could do is now we're going to switch from Bash to Ruby. And we'll have this rule class. And I'll show you the implementation of rule in a second. We're just going to implement this run method. It'll take in a file name and the actual code. We'll just run that same regular expression against the code, and if it matches, we'll generate this warning. Seems straightforward. The rule class looks like this. And again, I'm just trying to show you you don't have to necessarily know what all this does, but this is it. This is it. This is all you need. So we'll have this rule class. It'll keep track of our rules, the warnings that come out. Little convenience here, if we inherit from the class, we add it to the list of rules. Then we have this run rules method, which will take in the files. For each file, it's going to read the code, look at and then go through each rule, pass in the file name and the code, and then run the rule. So very straightforward. Then this is just to get the warnings out, and this is our warn method to just basically add the warning to the list of warnings. So that's all. That's all. All right, so going back to this, we'll want code to run it. So I basically just took the bash script and put it into Ruby so we can run multiple rules. Again, we're just going to check out that code, pass in the SHA as an argument, grab the file names that have changed, pass those to our run rules method, and then we're going to just print out each of the warnings that come out, if any. And then at the end, if there were any warnings, we're going to exit with error code 1. So if we're on standard Linux, that's going to be considered like an abnormal exit, and it will stop our CI job or our local job, whatever it is, and say like, hey, something failed. And we have the output right there. Any questions about that? Seeing some befuddled looks, but these slides are already actually posted, so you can go back and look at these afterwards. So yeah, you could just run it like this, just like we did the bash script, pass in the SHA that we want to check out, and it will generate these warnings. But there's some problems with using regular expressions. For example, all right, so this line isn't supposed to be wrapped, but imagine this is a comment. So someone's like, hey, don't use that, well, yeah, don't use that API. So they're actually saying don't use that API, and then we're going to flag that as they're using the API. That would be bad. Down here, amazing. We're actually defining a method getSurvey. Well, we're looking for uses, not definitions. So here we're running into the limitations of using regular expressions. We also have this problem where we run our regular expression looking for commas. There's a comma, and we go, oh, this has 2 arguments. It's safe. No, it has 1 argument. It's not safe. So, okay, our regular expressions have failed us. You could try writing a better regular expression, but eventually that's like more work than it's worth. Okay, so what do we want to do instead? So we're going to move from regular expressions to using abstract syntax trees. Interesting. So if you're not familiar with like how static analysis works, but you are familiar with compilers, they're very similar. We have the input text coming in. We're going to do some lexical analysis, pull out the different tokens, change that into an abstract syntax tree, which I'll show you in a moment. Then we're going to do analysis of that. Okay, this is a variable, it has that value. This is a class, that class represents, a controller or something. And then at that point, the compiler is kind of on the left, and yes, on the left, and static analysis tool is on the right. There were boxes, I don't know where they went. So a compiler is generally going to convert it into 1 or more intermediate forms from the abstract tree, syntax trees to something else. Some static analysis tools also do that. And then the compiler is going to like run a bunch of optimization passes, and then at the end, what do you get out? You get out like compiled code, bytecode, something like that. Static analysis tool, instead of doing optimization passes, which doesn't make any sense, it's going to be analyzing the code, and what you get out is not compiled code, it's a report of some kind, just like we've been generating on the previous slides. So I think that's a useful, way to think about how static analysis tools work. It's not like that mysterious. Okay, so back to abstract syntax trees. So here is a representation of an abstract syntax tree for our getSurvey call. So you can see the root of the tree is a call node. There's no target, so it's just empty. And then we have the name of the method, getSurvey. We have our arguments, which is a local, yes, called survey ID. So this is a little bit easier to work with than regular expressions, but generally they don't actually look like this. They'll look something more like this. This is the S expression representation of the abstract syntax tree coming from Lisp, so it's just a list. And again, we have the same thing somewhere. We have a call, no target. The name is getSurvey, and then we have an argument, which is a local variable named survey ID. Even more concrete example, if you're using Ruby parser like Brakeman does, you will get something that looks like this, which looks very similar to the S expression. And one minor difference is this is actually a call node here, because if you just parse this in Ruby, this is not obviously a local variable, it'll be a call. But you can see like we're getting something that maybe a little bit easier to manipulate than just the source code itself. And we have some information. We know that this is a call node, not a function definition, which our regular expression failed us on that. Okay, moving on. In Python, there's a library called Asteroid, which I find useful if you just want to pass in the text of the files. The Python standard library also has an AST library in it, but it's a little bit harder to use. Out of Asteroid, you get these. So this is like, again, we're still talking about abstract syntax trees, but different representation. In my opinion, a much more complicated looking one. But you can see we have, okay, it's like the whole program, that's the body. We have a call, and the function is a name, get survey. The arguments is another name, survey ID. And then we don't have any special arguments. And keep in mind, our scenario, where all we really need to know is that there's a call to get survey with one argument instead of two. So that's all we're really looking for. JavaScript, Esprima is a library you can use. There are other ones, but I think Esprima is pretty nice. You can see similar structure. You know, we've got our whole program, the body of the program. We've got some kind of expression. It's a call expression, and it's calling get survey, and here's our arguments. Okay, we'll come back to this. All right, so one approach is to find an existing tool and then add a new rule to it. So first one I want to talk about is called Bandit. It's from OpenStack. It's fairly new, not super mature yet, but we can add rules to it. So if we wanted to add a custom rule, it would look something like this. And again, I'm showing you this is all the code. You know, import some stuff from Bandit. We're going to add this annotation. So this is Python. And we're saying we care about call nodes. So just look at call nodes for us. And you have to give it an identifier. So this is just like made up. They have some like taxonomy for like 300s mean this, etc. You can look it up. Then we just implement this method, and they pass in this context, which is kind of like a convenience object. So all we have to do is say, okay, we know it's a call object because we asked for that. So we'll check for the function name that gets called. It's get survey, good. And then they actually have a method for call args count. That's all we care about. If it's less than 2, that's what we want to flag. So we just raise an issue here, you know, set the severity confidence, and you know, hey, you're using get survey without user ID. Yeah. However, a little bit of bad news. It's not very easy to get Bandit to use your custom rules. So if you're interested in Bandit doing static analysis for Python, I would suggest leaning on the Bandit team and asking them for an easier way to write. Writing the checks easy. Getting Bandit to pick those up is hard. You have to like modify Bandit and have your own build of Bandit to do it. But writing them is very easy. In fact, much easier than some other tool. Oh, no, sorry. This is the output that you would get. I know it's hard to read black on red, but just an example, you know, use of get survey without user ID points you to the code. Okay, so as I was about to say, that code actually looks much easier than what you would have to write for Brakeman. So if you're using Ruby on Rails, you could write a custom check for Brakeman to find this problem. It would look something like this. And I know it's a lot of code. I'm sorry. So we write a new check. We inherit from the space check. Well, you know, this is like boilerplate. And then we implement this run check method where we can find calls that don't have a target called get survey. And for each of those, ignore this junk. All we do is we look at the call that's in the result, and we check to see if the second arg doesn't exist. Remember, that's all we care about. So we picked a very good example for using static analysis and writing easy rules. And then we generate, you know, whatever warning we want, you know, direct object reference, you know, using get survey without user ID, confidence levels, etc. And if we run this in Brakeman, you can like have a directory where you put your checks. and we run it, and we can get out some kind of report like this. It's like, hey, you use get survey without user ID, and here's the code. So that's some examples of like using existing tools. However, if you're like me, you're like, I don't really want to use an existing tool. I'd rather just write my own. Isn't that easier? All right. So let's say we wanted to do some JavaScript analysis. You could use Esprima. I think it's easy to work with. Reminder, out of Esprima, we're going to get a data structure that looks like this, and we're looking for call expressions, get survey, one argument. So this is the entirety of the code. I apologize in advance. I don't know JavaScript very well. I should have apologized for my Python, but it was simple enough. I think it looked right. So what we're going to do is we're going to implement this method, and we're going to take in the abstract syntax tree. We're going to check to see if the node we're on is a call expression, check that the callee type is identifier, and the callee name is get survey. That's what we saw on the last slide. And then we're going to just say, hey, if there's only one argument, we're going to print out a warning. Again, I think you're probably getting the hang of this, right? And then the location here. And then we just implement this small function to actually walk through the AST. So if we get a node and it's an array, we'll walk each member of the array. Otherwise, if this is just like if it's actually an AST, not some literal value, we'll run this method on it. And then we'll run that method recursively down the AST. Very standard for any kind of working with abstract syntax trees, or any trees. And then we're going to load in Esprima, and then we'll parse our code, and you have to set this so that you get the location on the nodes, and then we'll pass that to our walk method. That's all we have to do. And now we're walking the AST. We're going to find those call expressions that are calling get survey with just one argument. Okay, what about if we wanted to use Ruby parser? So reminder, this is what you get out of Ruby parser. So in this case, we'll use the S expression processor that's kind of tied with Ruby parser from Ryan Davis. We're going to subclass the S expression interpreter with our new class, and then we implement this process call method. So this class will call this method when it runs into a call node. And then we just check, all right, there's no target on this call. And so I know this is like not a very useful interface, but this would be the method name. We'll check get survey. And this would be the second argument if there were a second argument. But we are looking for cases where there isn't a second argument. So if it's nil, then we generate a warning. And then to use it, all we do is pass in our code to Ruby parser, and then pass that to our code. That's all we got to do. All right. So I know that was like a lot of code, but that's the practical part of the talk. So if you're thinking I have like scenarios where I could use something like this, you can come back to this as a kind of a starting point for writing your own tools, or if you happen to use Python or Rails, you could use Bandit or Brakeman. There are other tools out there for other languages. So this is kind of just like to get you started and to demystify a little bit, like what it means to write a rule for these tools or to use static analysis. All right, so in summary, find a single small problem to solve. So in this case, it was, hey, calling get survey with one argument. And then you want whatever solution you end up building, you want that tailored to your environment. So I went through some of the automation strategies, pick the one that works for you or come up with a new one that works for your company. And then automate it, right? So that's kind of the key to the whole thing. If you just build a tool, but then you don't automate it, you're going to find it's not that useful, right? You want that automated enforcement in your workflow, preventing the bad code from going out. That is like our ideal state. Or maybe ideal state is no one writes bad code, but like that's even more wishful thinking, right? That's very hard. Okay, thank you. If you want to find me on the internet, President Beef, Brakeman, Brakeman Pro, the slides, you can go on Speaker Deck and look for President Beef. These slides are already up there, so you can refer back to them. And thank you for coming and staying and attending this talk. And we have time for questions if there are questions. Yes?
Yeah, so going through with everything you talked here, it feels like a security person is writing these rules. And so how would you effectively apply this? So if you have teams of developers that are like doing strong 2-week sprints and they're writing new code, how do you find time when you can start staying with them? Or is this waiting for like legacy code that's not really
So the question is, how do you keep up with a development team as code is changing? I mean, so it is true, you kind of have to start with like known problems that you want to find and solve. So yeah, but the fact that the code is changing is not a problem because you're going to write these rules once and automate them so that they're always running. And the nice thing about that is if you've identified a problem, you have a way of detecting it, you automate it, now you know that the code going out is not going to have that problem.
So this is like health checks?
Yeah, health checks, checking the code before it goes out. There's another question over there.
Where do you run it? So I was curious about where do you run the tool, because I feel, in my experience, there's this, if you give immediate feedback before the developer uploads the diff, it's very valuable, but getting it running on Mac, Windows, Linux, or all the different machines people use is painful. What's been your experience around this? Like, do you use the CI system? Do you use developer machines? Or just something else? Or also, like, are you able to block diffs? Because it's pretty painful to do that in GitHub, for example, to say, if you're using get survey with one argument, stop the pull request or something. Is that possible?
Yeah, so I talked about some options for that, putting it in CI, hooking it up with GitHub. I think that's probably a good approach because it's somewhat out of the way, because once you open a pull request, you're expecting your colleagues to review the code, and there's time there for it to occur. Running it locally, some teams have found that that's effective. I think for most developers, it's like a little annoying because once you're typing git commit and then git push, you're kind of done, right? You don't want there to be a delay between that and it actually going up to your Git server. So I think having it hooked up with GitHub and CI, that's probably the best approach. Any other questions? Okay, well, I'll be around, and if you want Brakeman stickers, I have those. Thank you.